So we start the design patterns. I will fix typo here. Okay, it's without the D. Okay, and this is the last part of the course, of the entire course, and the remaining 6 weeks, including this one, we will cover design patterns. Okay, and today we will start with a very short description of what design pattern is, and in 15 minutes we will start seeing design patterns. So a very brief reminder, until now we talked about source code quality. Okay, so how do we measure this? How do we define source code quality? And we started with basic principles, clean code principles regarding how you write, how you manage your code, how you name your variables. These are naming conventions. And after that, we dived into functions and classes, because we are in Java, and there we have seen principles that can be defined as solid, or keep it simple and stupid, or don't repeat yourself. And the main advantages are later, because at some point you need to change that, even if you don't want to do that. Maybe the client will want that, or the technology is changing, or the libraries are changing, or the algorithms are changing. So you'll reach a point in the near or far future where you need to change those methods. And that's the moment when you actually benefit for the decisions that you made now. Why? Because it will be more easy to read those functions and those classes. And because you can do that, it will be more easy to understand what you have done there, or your colleagues have done there. And in the end, by having all these 2 previous premises, the logic conclusion will be that it will be easier to change that, to fix it, or to refactor it, or actually change it. Okay, and after that, in order to be sure that, so by using clean code, solid, kiss, dry principles, the code can be easily managed. But we want to be sure also, when we implement that solution, that besides this characteristic, the functions actually work. And we covered all corner cases in order to avoid future bugs, okay, by trying to check all possible scenarios for our methods. And for that, we talked about unit testing, okay? And there we have tested if our functions, classes contain functions, if they are functional, which means for different input arguments, they will give us correct results. And sometimes you have seen that can be also an exception. Okay, so correct and right BCHF is another perspective on what means good code or quality code. And the objective of unit testing is to reach that point, but it's very difficult, even if you unit test a lot, because reality is too complex. Then we can imagine at some point it's very difficult to reach that goal, which sometimes sounds as bug-free functions, which means you have no bugs there, everything gets covered. But let's say we reduce that amount of possible bugs. So once again, we need to remind ourselves what's source code quality. And here you have all the properties that derive from clean code, solid, kiss, dry, and unit testing, okay? Because you have seen that when you unit test, the function will change, because you will see that you didn't cover some parts, or some very strange scenarios, like receiving null for a reference. And by doing that, you change the function. And after that, you have the refactoring part, where you rearrange the code. And if you have a function which is too complex to test, you will know it, because you will actually need a lot of effort to test it. And at some point, you will actually rewrite it. You will refactor it, because you realize that when you have implemented in the first place, you didn't were so clean, let's say, okay, about that implementation. So once again, unit testing, it's forcing you to, at some point, to see that function again from the clean code perspectives. Okay, so where design patterns fit here? So do they have any relation with all the concepts that we have described until now, like clean code, unit testing, and so on. And in order to understand that, let's see what are the forces that are against us. So we have seen this slide previously. So let's see what are the real problems of a software developer and what are the actually main reasons for not achieving the previous objectives or properties. So generally, we don't have enough time. And this is one real reason. Maybe it's top 3 reasons for not actually implementing a solution as you can do. Let's say theoretically, you need to do that and that, but practically you don't do it. And the main reason in most cases, like I said, is available time. Costs. Now, costs are related with available time, because if you have an infinite budget, it means you can stuck on the same module for months, maybe years. And if you have an infinite budget, maybe you don't have any client, maybe you are the client, and I don't know, you just want to avoid getting bored, and you just spend those money to create the perfect software solution, and maybe you will never achieve it. But generally, if you have a client, you already established some initial costs and you have a budget. And if you do a simple math, like what's the cost with the salaries of your team, okay, you will realize that getting that budget, that the contract value, and divide that contract value with the monthly operational costs. And one big part here is the salaries, the wages of your team. And you do that division by considering only these costs, you will get a limited period of time. So costs generally determine the available time. Now, in operational costs is not only your team members' wages, there are other costs like, I don't know, the rent for the space, different services, maybe you need to buy licenses for libraries, whatever. So wages, yeah, they make the most part of your operational costs, but generally they are not all of that. Okay, now another problem, and we talked about this. Every time you have teams with programmers with different levels of experience, okay, just remember that each time you get a junior, and that will happen a lot in the next years, you will gain experience, you will become, let's say, a senior or a more experienced programmer. But every time you have a new colleague, which will, let's say, graduated that year or maybe less than 3 or 4 years, he or she will be with the same level as you now. Okay, so you have these teams with different levels of experience because it's natural to happen. And sometimes your team members will leave, they will switch to other projects. So there is this dynamic which will alter the level of experience in your team. Okay, once again, competencies, specifications. Okay, maybe you don't wrote that, maybe you have another team which is focused only on designing the system architecture and also giving you the specifications. You depend on that. Maybe they are not clear, or maybe they miss something. Once again, they may change, or they are not clear and you don't really understand what's there. And, for complex solutions, we have also on top this part, the complexity. Now, for a simple solution, it's easy to manage it in a limited amount of time with a limited team members. But for complex ones, once you start bringing in other modules, integrating different other APIs, so you have other external reasons for failure, now that will become more and more difficult to manage, okay, and to implement. Okay, and the change. We all know that the change is constant. And at some point, either we or the solution or the client will change from several reasons. Okay, so what's the opposite? Because in order to understand design patterns, we need to understand what's the opposite, because this will be our first mark by being able to identify a solution that is not clean based on design patterns. In order to identify that, we have a bad solution, and that's the point when we should realize that we need to refactor it in order to introduce a design pattern that will help us manage that solution in the future. Okay, based on the change perspective. So the opposite of a design pattern is called an anti-pattern. And here you have different names for it. Now, one name is this spaghetti code. And you will hear that from your more experienced colleagues, maybe in the code review phase. So generally, if you mess up things there, they will see it and they will just say that to you, like, okay, you need to refactor that. It's spaghetti code here, okay? So spaghetti code generally means this picture. Now, this is an example of an old phone central. Now, back days, maybe, I don't know, 80 years ago, when we didn't have the digital phone centrals. Okay, they were all manual, and you had an operator that was actually creating physical links between the caller and the calling person. Okay, so you have this spaghetti code. So at some point, you will, because you maybe don't have any rules here, the links are just mingling between them. At some point, you will lose yourself here. So you want to end the connection, you will not know which one to end because you have all these cables mixing each other. Okay, so this is actually spaghetti code. Now, in terms of source code, spaghetti code means, from a function perspective, something like this. You have an implementation, and there you are calling other methods from other classes. Those methods from there are calling back methods from your class. So if you want to go in debugging and trace your execution by executing it step by step, you jump from so many modules and back, and you have a very high call stack. So it will never be unclear why and how you got an exception, or why you have a different result, no exception, but the result is not okay. So if you start tracing that by using the debugger, you will actually, even if you use a piece of paper, you will actually feel lost in so many calls. Now, an example of implementation will generate something like this. A high number of calls from different modules or to the same module is sometimes recursion, or using multiple threading programming. Because at that moment, the call stack can increase very fast, and for multiple threads programming, you have different call stacks. And that's why in these scenarios, it's very difficult to debug. It's very difficult to follow the execution through those call stacks. And in multiple threading programming, sometimes, depending on what tools you are using, it's very difficult to see the thread call stack, each thread call stack, and to follow that. So this is the term of an anti-pattern, spaghetti code. Okay, so it's very difficult to follow the execution. You have big functions, complex ones, with a lot of calls to a lot of different other methods. Okay, another definition will be duct tape and bowling wire. So generally, this is when you patch a function or you implement a beta version, and you just patch it based on unit tests, based on requirements. So you just write their stuff, add another if, add another switch, just to make it work for the moment. Now, the problem is, how do you leave that for future changes? Because if you don't refactor it, you will have a lot of problems in the future. Okay, and let's say another known term is this big ball of mud. Okay, and has been defined by Brian Foote and Joseph Yoder. And if you search for that, it's a paper with that name, a big ball of mud. Okay, and this is the definition from them. But generally, spaghetti code, it's more frequent, or big ball of mud. Okay, so this is an anti-pattern, and you can just imagine a source code which is generating the links that you have seen, you are seeing in that image. Okay, now another example from real life is also this image, and maybe you have seen this at news. This is the kind of urban, let's say, development in developing countries, or maybe in some of the Latin America countries, where you have this discrepancy between normal urban development. So everything is, I don't know, designed as a grid. you have facilities, and after that spaces, commercial spaces, houses, offices, and so on. And near that city, let's say official one, you have an unofficial city which has been developed like this, okay? And generally, this is the kind of, let's say, poor neighbors and people with low incomes. They are struggling to create something that they can call their own home, but the development is a chaotic one. So they are just using the spare space near the city managed by officials, and they are just filling up the gaps near that or in between. So this is another thing that we can relate with a chaotic implementation of a method. You just add new methods based on current requirements, and at some point you realize that the big image, the overall image of your implementation looks like this. And this is very dangerous because you can't actually make a sense here, or if you just want to, I don't know, design a path that will cross this image on a diagonal, you can't do that. The only solution is to raise everything down or delete and start again, okay? Because otherwise, if you try to mix this stuff, move it in order to have maybe a clear path through that, it's almost impossible. It will cost you more than the time and the resources that you need in order to start that from scratch, okay? And this is also available in coding. Okay, when you start and just add new functionalities to your classes. How can we reach this this image in source code? By using throwaway code. So these are temporary solutions that we implement just to show that the algorithm may work, or just to give a very simple proof that the solution is doable, and you don't refactor that. Okay, you leave that in place because, I don't know, you don't have time. So you add other prototypes. And if you continue in this way, you will reach this scenario. Cut and paste code. Remember dry. That's why it's important, because by copying code, you copy bugs, you copy complexity, you copy all the problems that that source code has. And on top of that, you create new problems. Because if you need to change that copy paste source code, now you have another complexity problem, because you need to figure it out where you have copied. Okay, so besides the problems in the source code, you have another problem. How do you manage all these clones of the same source code? So that's why dry, it's saying to you, don't copy paste, use functions. Okay, adapting code by commenting. That's why you have the recommendation from clean code. Don't comment code, don't create zombie code. Don't create alternatives by switching the comments between different parts. Okay, use Git for that, for example, but don't comment your code. Okay, and now real life will also force you to make mistakes, design mistakes like this, very short, unrealistic deadlines, lack of experience. Now, lack of standards and procedures, that's something that your company or your environment needs to fix fast. So every time you work in a team, if you don't know each other, or you have new members, or you have a dynamic team, every time before you start working together, you need to set the common grounds. Okay, how do you code? How do you do the code review? Who is writing the specifications? Who is testing? And so on. And this is generally given by different standards and procedures that you need to have in place. Okay, and companies today, because they sometimes need to certify in order to prove to their future clients that they have a quality process regarding how they develop software, those certifications, in most cases, they require some standards, and you need to prove that you have those standards in place and everybody is following them. What's the goal? This image. So if you switch back and forth between the two images, I think everybody appreciates the new image here, where everything looks clean, everything is in place, everything looks that each element is in the right spot. And I think at this point, you can actually do simple changes, you can update that stuff, you can refactor it easily. Because you see, by just seeing the broader image, everything looks in place, everything looks clean. Okay, it's easy to identify items. They are not correlated. You can see standalone points or individual points in this image. Okay, so this is actually the goal that we follow by using clean code principles, and unit testing is helping along the way. So generally, if you remember TDD, test-driven development, the function is written in steps. You start with the basic implementation, let's say return 0. You do a write test, which will obviously fail. After that, you refactor the method by implementing the algorithm in order for the write test to pass. So it's again the red, fix, green, okay, the cycle of TDD. And after that, the function will increase in complexity. And we had examples where we covered that part. So in the end, you have a function that passes all tests, which means it's covering all cases, all functional cases. And now what do you need to do? Just to check it again. And if you see redundant stuff, or if you see a complex infrastructure of structure of ifs or a switch, you can refactor it by applying clean code principles. Maybe you have a dependency on a concrete class because you need the method from that class, remove the dependency using interfaces, and so on. So this is the phase where we change and improve the quality of our code. And we did that when we talked about clean code. And the term you already know, it's refactoring. Now, from this moment on, when we will refactor a solution, and maybe this will be at class level, not at function level, now refactoring will also include design patterns. So you will have a different perspective from a higher point, like from the class level point, on all your methods and the class itself. And design patterns will help us refactor the class. Okay, because until this moment we talked only about refactoring methods, but design patterns you will see they are actually elegant solutions or clean solutions to manage a class, to manage its scope, its functionality, seen as a broader image. Okay, you don't care about the details, you cover the functions by clean code principles, and now you want to cover the class itself in order to make it more clean. And for that, we will have design patterns. So once again, refactoring, now we will include this extra step by introducing design patterns or identifying a design pattern and redesigning the class. So what's a pattern? Now, a pattern is like a piece of a puzzle. Okay, you see the image here, which means it's a piece which has a specific shape. Okay, it's inflexible from this perspective. You have a shape, a given shape with these details, and you can't change that shape. And now, in order to fill up the puzzle, we know that the rules of the game is to do what? To place each shape in its location. And each puzzle shape has only one location. Okay, you can't mess them up. So each piece has its own place in the final image of that puzzle. And from this perspective, this is actually a design pattern. So a design pattern is like a piece of a puzzle. It will always have a fixed shape. It will always serve a single scope. Okay, and that scope is actually a problem. And you will see that there are actually several standard problems in coding. Some of them you already used in other courses, and you never realized that you were actually solving them by implementing in the only right way. And you were actually using design patterns. And you actually started using design patterns since you started the Windows application programming course in second year, second semester. And after that, you used other design patterns during the Android course, the Android development course, and also in the web technologies course when you use Node.js and you develop single page applications. Okay, so you have some experience regarding design patterns, and you maybe you didn't saw those patterns because my colleagues were like focusing you on little steps in order to understand the architecture, the framework. And sometimes they gave you the solution. It's like, hey, if you want to provide a handler for a click event for a button, this is the way you do it. Okay, you define a function and you, here I'm talking about Windows applications and the .NET framework, you define a function. That function was called a delegate, and you register that function to an event. Okay, and they said to you, this is the way you can add functions that will be executed when you click a button or you sort your list or whatever. So you are actually using design patterns. And because there was only one solution for that problem, that was the solution they showed it to you, and you just took that as granted and use it in order to build Windows applications. And the story continued with Android and also with the web technologies. So a pattern is a fixed, let's say, shape, which is actually a solution for a defined problem, for a known problem that has some characteristics that we need to identify. Okay, so it's like a puzzle piece. You can't use that puzzle piece for filling up another location. Each pattern has been designed to serve and to provide a solution to only one problem. Okay, so from this perspective, we know that for each design pattern, we need to focus our attention on this to understand the problem in order to be able to see it in the future in our own solutions. And secondly, to understand that for that problem, we have a standard solution, we have a standard implementation of a solution, and that's the pattern. So you see, the biggest problem here, and that will be the problem for the rest of the remaining weeks, is not the pattern itself, because we will have UML diagrams for them. You can use those diagrams for the exam. So the solution will be in front of you in terms of a UML diagram. The actually problem is not that, is actually to see the problem in the context. Because it's like, once again, I'm using the same equivalent with the puzzle. If you try to use the pattern to solve another problem, that will not fit. Okay, in the end, you will have something which is not the intended final image. Okay, you just force things into places in which they don't belong. Okay, so each pattern should be used accordingly with the problem that it solves. And this is actually the biggest issue here with this part, not the implementation itself, because you will have help on this. You have the UML diagrams, which are saying to you, hey, if you want to implement that pattern, you need to define those methods, and that's it. You need to integrate that in the solution. But the actual problem is how do you identify the problem in order to choose the proper pattern. Okay, so if we want to conclude that to a definition, this should be the definition. So a pattern is a reusable solution for a standard problem, you see, which means that we can use it again and again and again for the same problem. And we need to be able to see the problem, because based on this knowledge, we are able to choose the solution for that problem. Okay, because otherwise you can choose differently and things will not end with a success. Okay, you will actually create another issue. Now, a very important disclaimer is they are not data structures. Even if we are using data structures to implement the pattern, they are not data structures. They have a different purpose. They are like functional patterns. Now, a data structure is a data pattern. How do you store some values in order to provide fast access, fast insert or delete operations? Okay, so that's a data structure. It's a pattern for managing data in certain conditions. Now, a design pattern is not a data structure. We will use data structures to implement some patterns, but this is not a design pattern. Okay, you can change the data structures if you want. You can implement your own way or create your own data structures, but a design pattern is not a data structure, okay? So I want to make this clear before we enter the design patterns. Now, you have here other descriptions. Maybe they will help you see what's a design pattern, okay, from different authors that they have published books in this field of design patterns. So you can read their definition or description, and maybe that will help you see more clearly what's a design pattern. Now, the advantage is, like I said, I already covered this part, because when we talked about what's an anti-pattern, like big ball of mud or spaghetti code, it's obviously that by using a design pattern, you avoid all those problems, and these are your advantages, okay? And another advantage is that these design patterns are standard. So they have a standard definition or implementation, and this will also help you work with your team members, because if you know what a singleton is, and they should also know this, because a singleton is a definition of a specific design pattern. Everybody knows them by their name. And if everybody knows what a singleton is and you implement one, you will actually say a lot of things about the source code without writing comments, because they will see the design pattern, they will see the singleton, and by knowing why you have used it and what's the advantages for that solution of a singleton, they will be able to understand your solution and also to change it if they need to do that. So you see, once again, we use a common vocabulary, which in this category translates to standard implementations for a specific problem, and that standard implementation is actually the design pattern. And using this common vocabulary, we can actually talk to our team members in a way that we say things in a very clear way, okay? So if you are saying, hey, I'm using a command pattern to handle those asynchronous tasks, they should know what's a command pattern. You are already saying a lot of things about your solution, okay? You don't need to describe what's the purpose of that class or that interface. They will see the pattern there because it has a standard implementation, and that will be the UML diagram that we will use for each pattern, okay? So once again, we extend our vocabulary, and using the pattern names, we can say a lot of things about our solution. Now, how they define the patterns. This is very interesting because the story starts from the end to the beginnings. Like, it's a reverse engineering story, because the design patterns, they were not defined by, let's say, a group of people that they just sat at the table and they were just saying, hey, I have this bright idea, let's invent the design pattern concept. And by this, I will define a set of standard problems. And for those problems, we will define standard solutions. So they just invented the design pattern concept. No, the story is actually a reverse engineering story, because experienced programmers were trying to solve problems, performance problems, bottleneck problems, deep problems, dependency inversion problems. And when they started looking around, asking on forums, hey, how do you do that? What's the perfect way or optimal way to do that? Or how do you handle that? They realized that in the community, the solution was already defined, but it didn't have a name. So it was just like asking around, and at some point you realize that multiple different persons will say, hey, you need to do that and that and that. And the community after that moment accepted that response or that implementation to be the optimal one for that problem. So by using their experience and realizing that in reality, there is a common set of problems for which the community has already established the standard solution, they said, hey, let's standardize these solutions and let's make a collection of them. And now you have those design patterns. So what it proves this is that all your design patterns, they already have passed the test of time. They were already used by the community and the community proposed those solutions based on their own experience, based on their own solutions. And now you just take those already tested solutions and you name them. And you create a collection that everybody should understand and read in order to avoid asking this again. Hey, I have this issue. What do you think is the perfect solution for that? And now you have the collection of design patterns. So, and this is a variable property because they are already tested. They already proved their efficiency. So these guys, they just collected them and named them. Okay, where are we here in terms of software architecture? You remember at unit testing, we were at the bottom of anything that can cover testing, software testing. Unit testing is at the base level. We test our own functions. And you remember the diagram with all the upper levels. And the last one was the acceptance testing, which is done by the client. Now, in terms of design patterns, and from a software architecture perspective, now we are not, as for unit testing at the bottom, we are the next level because we already use some architectures, common architectures, and those were the object-oriented programming principles. How do you store your functions and data? It's a principle by itself, the object-oriented programming. So you see, because we are all programming object-oriented languages, the first architecture which we use is how we manage our source code based on class definitions. So this is the first level. Now, design patterns are on top of it. So like I said, design patterns, they will actually help us manage a class or manage the relation between different classes. So we are very close to classes, which is the bottom level. Now, from this point on, multiple classes that are implementing design patterns or frameworks, collection of classes which are managed by using a pattern that defines a framework. So we are moving from micro level to macro level. And from this moment, you go up to application level, you have subsystems or modules, and system level where you have the architecture of your entire solution. Okay, and after that you have enterprise level. So yeah, we are still very close to source code, okay, because we are here, okay, design patterns and object-oriented. Now, for a pattern, what do you need to remember? So the stories that will follow after this slide, they will focus on these 4 items or 4 properties of a design pattern. And these are the things that you need to understand, learn, but mostly understand, because I avoid saying memorizing because it's much more valuable to understand how to use them in order to just memorize some examples. And for this reason, we are allowing you to use the UML diagrams as a cheat sheet during the exam. Okay, don't memorize them. You need to be able to adapt them to certain solutions. So the 4 properties of a pattern are name, and this is standard. So if we say command, if we say singleton, if we say observer, any of the keywords that you will see, they are standard, okay? So don't try to say to a singleton by using a different name, like the class that doesn't have a public constructor, okay? We will use singleton. So the name is important, and you will actually learn it because we will say it multiple times during the course. And in the end, the idea will stuck in your head. The name will stuck there. Okay, now, like I said, the problem, and this is actually the biggest issue with patterns, we need to be able to understand what's the problem that the pattern solves, okay? The solution is standard, so a singleton will always be implemented like that, or a factory, or a builder, or whatever. So, and for that you have the UML diagram, okay? Which you don't need to memorize because you can look at that at any moment. And the last part are the consequences, or let's say advantages and disadvantages, because sometimes a pattern can become an anti-pattern from a performance perspective. For example, a singleton can become a bottleneck for your entire solution. And in that case, from a performance criteria, it's an anti-pattern. It should not be used there because you create a bottleneck. You will slow things down. And if that matters more than the pattern itself, you should not use it, Okay, so you will see that for each pattern you have advantages and disadvantages. Okay, and we will get to the same conclusions together. You can also deduce some of them by understanding the pattern. Now here you have a very brief history of how the concept has evolved. Okay, and which were the first models. Now in terms of, let's say, design patterns as the concept that we know now, this is a very important moment. You have these four guys, they have published this paper where they actually emphasize this reality that in the community there were some optimal solutions for some very clear problems. And they just realized that by using their own experience, by using their own search for optimal solutions in different cases. And they actually realized that the community had already defined those solutions. Now, maybe they didn't have a name. So they present this concept of a design pattern based on their practical knowledge. Okay, and in 1993, and after that, everybody agreed that it's a very good perspective. We need to standardize this, and you have this book. And this is the most popular computer software book worldwide all the times. Okay, it's the book with the most sales, the book most referenced, the book that any programmer should read. In top 3, you have the Clean Code book from Uncle Bob. We covered that, or I said already to you that that's the support from Clean Code. What's interesting here, when they wrote this book for the first time, it was written in C++. After that, you can apply these patterns in any languages: Python, JavaScript, Java, we are using Java, C#, whatever. Any language can have its own implementation of these design patterns. And that's why it's top 1 computer science books, because at any moment, any programmer in any language will come back here and try to reuse these standard solutions for common problems. Okay, and now if it's easier to remember, if it's harder to remember their names, the 4 authored names, everybody, let's say, reference them by the Gang of 4. So if you read tutorials, or if you search on Stack Overflow, you will see this reference. Hey, if you search in Goff book, which means the Gang of 4 book, check the whatever command pattern. Okay, so this is the common name that everybody is using to reference the authors. Okay, the Gang of 4 or Goff. Now the book describes 23 patterns, and some of them are, let's say, too complex to be covered in this course. We don't have the spare time to do that, so we will cover only 18, if I'm not mistaken, out of those 23 patterns. Some of them are architecture patterns, or patterns for multiple threading programming, and we don't cover that part. And also they are very complex. You really need to understand multiple threading in order to understand those patterns. So we stop at that point. Okay, and like I said, you already have used patterns. This is a list of them. You will understand them during this course, but if you want to check which patterns you already use without actually knowing that you are using a design pattern, you use the observer in Windows applications, you use the observer in Android development. Maybe if you play with Java Abstract Window Toolkit or Swing, you also use observer. Iterators were used since standard template library in C++, if you remember that part. And also anytime you are using a collection in Java, the enhance for, it's using an iterator. Facade, it's anytime you are using an external library, you are using a simplified interface of the classes which are in that library, in that framework. So anytime you use the framework, you use the facade of it. Bridge and proxy, now if you cover multiple or socket programming, maybe you cover this part. And Singleton, if you are using Hibernate or Hibernate for a data layer that will manage the connection to the database. Now, we structure these patterns in these categories. So we have three categories: creational, structural, behavioral. Everything that we will talk in creational, it's all about creating objects. So common problems to creating objects are covered by creational data pattern, design patterns. Structural, it's all about the relation between classes. How can we link them? It's all about deep dependency inversion and how to handle that. And behavioral, it's all about handling tasks. You will see a pattern for asynchronous programming and other tasks. So every time we need to solve a problem with the behavior, observer, for example, it's a behavioral pattern, we will have this category of patterns. So they are all related with actions, how that object will do that, okay? Do the action or handle different actions, and that's behavioral. So you have creation of objects, relation between classes and objects, and behavior of objects. These are the three categories. This is the list of those patterns that we will cover. So we will go, and you will have another slide reminding you this. Now, here you have a short description. Now, if you cover this short description of the patterns and it's like you have no idea what's there, that's a good feeling, because after the following weeks, we will come back to these slides. And at that moment, you will already have a comprehensive or a simple of the understanding of the pattern, and you will actually understand each phrase which is actually describing that pattern. And this is the added value of what we will do in the next weeks. Now, I will start with the first one because I need only 10 minutes to say what's it. So remember, creational design patterns are all about creating objects, and these are the patterns that we will do. So the first one and the most easier pattern in the world is Singleton. Now, you have a large community which are saying this is bad. It's an anti-pattern in most cases. Now, it's still in the book. And like I said, you will understand its disadvantages, and maybe you will understand later why others are saying that this is actually an anti-pattern. Because the disadvantages in some cases are very harmful to your solution, especially to the performance. You will have a single point of failure or a bottleneck for the entire communication, traffic, and whatever. And this influences a lot the performance. So what's the Singleton pattern? These are the problems. And every time I will try to give you a brief description of the problem. So generally, a Singleton is, by what it names suggests, it's a problem where you need to create only one object. So you are in a certain solution where you have a class, and generally, we can create multiple objects of that class by just creating objects, call the constructor and create them. Now, the problem here is that you don't want to allow that to happen. So how can you give me a class that I can use to create objects, and how can you force me to create only one object? Because if I have access to the constructor, no one will stop me to create any number of objects. Now, why would you try to do that? For example, when you manage a connection to a database, and I think in your bachelor applications, you all play with connections to databases at some point, either in your application or in your backend of your solution, you play with the database, you connect to a database. Now, what's the problem with this? The problem is that a database will allow you generally a limited number of connections, because each connection requires a socket that requires memory. Okay, you don't have infinite memory. So let's say your database allows you only 20 connections at any moment. So you create a module that will, let's say, you use it in order to define the interface of your client. And because when you develop that solution, you are the only user, you write the code, you test it. So you will create a connection in that module, okay? And you will use that connection for the remainder of the session, okay? Until you will close the application. So at this moment, everything works okay. You are using that connection, you keep it open to the entire session until you close the application, everything works Now you test this with your Q&A team, and maybe you have 2 or 3 or 1 tester which is allocated to your project. Now you will both work with the same application, your colleague will test it, you develop and make your own tests, so everything works without any issue, because at this point you are using 2 connections out of those 20 maximum possible. Now, what will happen if you deliver that to your clients? What will happen if you have more than 20 users? Now, you see the problem, because more than 20 users trying to use your solution at any moment will not be able to access the database because you don't have any available connections. So in this case, maybe each module of your own application will create its own connection. So let's suppose you have 30 modules. So you can't use all the modules from your solution because you exceed the maximum number of possible connections, 20. So a single instance of your software solution will eat up all those available connections. So at this point, you need to ask your colleagues, hey, don't create your own connections in your own modules. I will give you a reference to the unique connection. Now, what's the probability that they will actually use that and maybe they forget and create their own connections in different functions? So you see, this is a common problem. So this is a problem where by design, you should not allow anyone, even you, to create more than one object, to create more than one instance of that class. So this is actually the problem. So every time you see this problem, we need to create only one object. We should not allow others to create more than one object, okay? And you see, in the end, the conclusion is that your entire solution will have a single object, a single instance. And this is the name for the pattern, Singleton, because in the end, that will allow you to create only one object. It's not asking. They can't do it otherwise. So this is the problem with the Singleton. It's actually a class that will allow at any moment to others and you to create only one object. So how do we do that? This is the standard implementation. This is the UML diagram of the Singleton. Like I said, it's the simplest patterns ever. So normally, if you have a constructor here, and let's assume it's not private, it's public, this is not a Singleton. So always watch out for this kind of stuff. Always watch out if you allow me to use the constructors. Okay, so the constructors should be private. Now, if you don't write any constructor, I remind you that you get one, which is called the default one, and by default it's public. So by not writing a constructor, once again, that's not a Singleton, because I can use the default constructor. So if you define a constructor, it's mandatory to define it private. Now, if you give me a class with a private constructor, no one can use it. It's just a class, I can't create objects. So what's the solution? How can we do a workaround around this? Like, we have a class with a private constructor. How can we use it? Because at this point we can't. And this is what the UML diagram is saying to you. All your constructors should be made private. Remember the minus, this means a private resource. And here we are in the function section. So we have a private function, which should be all your constructors. Now they will give you a hint like, you see the constructor, it should be private, and you should understand that any other constructor should be also private. And at this point, the class is useless. Now, inside the class, we define a private attribute, which is called the unique instance or the object or that object or whatever. This is your unique instance. It's actually a reference to that unique object. So we define here a reference, and this is the trick. That reference has the same type as your class. Now you use that before at data structures. Remember the node structure for a simple linked list? It had the pointer to its type, and that was the next pointer, okay? Now, generally in a class, this is very strange to create a class that has an instance with the same type of its type, which is an instance of a Singleton type because the class here is called Singleton. So we define this reference, and once again, it's private because I don't want to give you access to it. I want to control that. So, and this is the let's say the third part that completes the solution. Now, if we stop here, once again, the class is useless. You can't create objects because the constructor is private. You can't access this reference because it's private. But if you are the owner of the class, here you can create this instance. Why? Because if you are the owner of the class, you are the only person now that can use a private constructor, either this one or any other constructor, a private one. Remember, private resources can be used only by the class owner. They can be used here. So I will create a public method, and this is the thing that you can use in order to get that unique object. Once again, it's a static method. Why? Because if this method is not static, you can't call it. Remember, you can't create objects. How can you call a class member function if you don't have an object? You can't, because that function will need a this, which is the reference of the calling object. So it's mandatory to make this method static, because otherwise it's useless. It's a bad joke. It's like showing me the solution, but I can't use it. So this is very important to make it static. Remember, calling static methods, you don't need objects. They don't get this. And I will define this method public, static, just ignore the synchronize for the moment. And this method will return this reference. So the method is mandatory to return a reference with the same type of your class. And generally this method is called getInstance or get me that object, or it will have only one purpose, to give you the reference to that unique object. So what do we do here? We check if our own private static reference is null, and is null by default. And if that's the case, I will create that unique object because I can. Here it's my class. I have access on everything which is defined private here. So I will create that unique object and I will return it. From this moment on, anytime anyone will call this method, the if will not execute because the instance is already created, and you will just return the reference to that unique object. And this is the singleton. And this is the UML diagram that should help you see this, okay? Define an attribute with the reference type of your class, make all your constructors private, and implement a public static method. It's important, static, because otherwise it's useless, called getInstance or getObject, and this should always return this reference. And here you do this. And this will assure you that if I want a singleton object, the only way to get it is to call getInstance. And here you will make sure that this constructor is called only once when I'm calling this method for the first time. So this is the singleton, okay? And it serves only one purpose: help you create classes that can have only one instance. And this is the way you do it, okay? By using this, this approach. And here you have a short description of it. Now, in Java, we can have other different ways, and I will show you. By using a static private attribute or a static public constant attribute, you can actually have 4 versions, also including an enumeration. So 1 minute, and just me share Eclipse, okay, where you will find these examples. And next time I will maybe go through them, just remind you. So this is an example with a DB connection, okay? And here is the standard singleton with the private constructor static method, like you have seen in the diagram. This is how you can do it in Java, because remember, in Java, an enum is actually a class, a special class, and this is actually a constant reference to an object. And this is how you can do a singleton in Java. I will upload on Git this example so you can read them in detail and understand what's here. I'm just showing them to you. So this is the same thing you can achieve here by an enumeration, okay? Because by default, each symbol in a Java enumeration is actually a singleton. And this is another way by using a static constructor. At some point, I told you that in Java, there is this concept of a static constructor, and for some design patterns, it's useful. So this is a static constructor. It will be executed only once when the class is loaded by the Java virtual machine and compiled. Okay, and you see it's a more simple implementation of the standard implementation, because here you just play with the static constructor. You don't need the get method, and you make this reference to the unique object static and final. So no one can change that in the future. And because of that, you don't need to define it private again. And you will use the static constructor to initialize this only once. Remember, this is executed only once in the lifetime of this class. Okay. And once again, the constructor is private. Okay, so this is the kind of stories that we will see in the following weeks. We will go through the other patterns, okay, and at the end we will talk about advantages and disadvantages. For singleton, I already enumerated the biggest disadvantage. It can become a single point of failure, and it's a bottleneck. If you manage your database connection, everything will go through that connection. So it will slow things down, okay? And for this reason, some are saying the singleton, it's actually an anti-pattern in some cases if it's not used properly. So this is the idea of a singleton, of a pattern, and I started with the easiest one. And yeah, some of them are much more complex, but the idea was to realize what's a pattern and what are the things that we need to focus on. Like I said, and this will be the closing remark, the problem is this: to understand the problem that the pattern is solving.